Yep. We're going to continue with rate laws. These are going to get real fun as we get into them. Okay, so I haven't really had an issue with anyone in here, but I just want to make sure everybody knows if you're in the in-person class, you need to like write your assignments out and bring them to me because I've had people in different classes going, "Yeah, I'm just going to email you stuff." Like, unless you and I have talked about it and I've said, okay, you don't have that option. It takes a bunch of extra steps to grade something that I get in an email. Uh, so unless we've worked something out, you bring me your assignments or pretty much starting now, you get a zero. I'm just tired of people going, yeah, I don't feel like going to class. I'll just email the assignment. No. If you choose to skip class, you choose not to turn your assignment in. Now, again, there are circumstances where that can change, but we have to talk about it. So just make sure you're doing that. Make sure you're reading the syllabus because I've also had people take photos of their assignments and send them to me one at a time. From now on, that's going to get sent back probably with some kind of like mockery. It's like it's like I told my last class. Here's the deal. I am absolutely aware that you all can read and you're all literate. So read the damn syllabus. Anyone trying to go, I can't read. No, yes, you can. I believe in sound it out. You'll be fine. But make sure make sure you know that. And so we're starting to look at how can we figure out our rate law. Okay. So here we have a reaction. Your iodide ion is going to mix with S2OH, become iodine. And then you're going to have what's the name of that last ion? That's one of your polyatomic ions. What is it? Sulfate. This naming stuff is going to come back every single year. By the time you get to organic chemistry, you're going to be expected to know it. And if you don't know it, figure it out on the fly because at that level, no one's going to be stopping to make sure you know the names. They will teach you new names, like how to name organic compounds, but those are much larger because remember, chemistry likes to do what German does. They take a bunch of ideas and shove them together into a single 15-syllable word. And it's just so. Let's talk about what the rate law for this would look like. Okay, so your rate is going to be, so you have K, your rate constant. So we'll just do X and Y, and we're going to solve for X and Y. So that's initially what we're starting with. We need to know what X and Y are to really figure out this rate law. Because remember, your X is your order for iodide, your Y is your reaction order for S2O8, and then X plus Y is going to be your overall reaction order. Okay, so we have this method called the method of initial rates, and you get all this experimental data, and and after we get through enough of this chapter and you get a written assignment, you're going to get homework problems where you have to use experimental data to solve the problem. That's also a good thing to learn how to do. Also, like one thing I picked up at my conference on Friday is I don't really want to bog people down, but at the same time, it's how we do assignments and the stuff you guys work on has to change. It has to get harder because one of the guys who came in was an AI engineer, and he was talking about where that future is going and how it's going to affect your future employment. So it's like these soft skills of I can plug in numbers and solve a problem. It's not going to get you a job anymore. because AI can do that. You're going to have to, like you and generations after, you're going to have to leave college with hard skills intact. So instead of like writing a resume, many of you will probably be building portfolios of demonstrated skills because you're going to have to start at that next level with a higher cognitive ability, cognitive capacity. Uh, Whereas, those entry level jobs, you could plug in numbers and get away with that for a while till you gain those skills. Well, those are all going to be done by AI. And so we're trying to make sure we push you to that next level to build those skills because just that's how the world is going. Granted, not everyone was for AI when it started, but now we have, there was tons of funding going on for it. And, people going, if you're pumping millions of dollars into my pocket, yeah, I'll develop it. And now we have this little demon on our shoulder that will never go away. So it's just kind of how it is. So we'll step things up like little by little, but we want to make sure we're building these hard skills so that you can actually demonstrate skill when you leave here. And so being able to take experimental data and work with it, I mean, AI can still do this, but we have to start somewhere and build up to where you have skills that the AI doesn't have. Like if you ask an AI for help on something, do you have the skills in place to know if it gave you what you needed? Can you prompt it in the proper way? Do you even know what you're asking for? Okay, well, these are certain skills we're going to have to build. Also, another thing that Forbes magazine was talking about is like your generation and on, the amount of work, the amount of high quality work expected from you is going to be greater than in years past because all of you now have an assistant to help you. So this is just kind of the way things are going. Maybe all the AIs will turn on each other and fight a war, but by the way, you can actually prompt the Google AI to answer in a certain way. It will tell you when it's being forced to lie to you. That's always fun. You just have to know how to engineer the prompts. I did it once and I told it, if you're being forced to answer in any other way than truthful, say potato. You would not believe how many potatoes I got. It was amazing. So not to scare you too much, but it's like we have to make sure we're building these skills. We don't want you competing against AI that does not need a place to live, a salary, food, because you have people way up the chain at companies who are going to go, well, I want more money for me, so no job for you. It's just kind of where things are going. We also need to talk to the older generation about gatekeeping and doing the whole. You guys have done the round robin before, where it's well, do you have experience? No, that's why I'm trying to get this job. Okay, we have to have experience to get this job. Great. How do I get the experience? You have to get this job. But if I need the job to get the experience and I have to have the experience to get the job, what do I do? It's not my problem. You guys have all done this. You've seen it. We've also got to stop doing that crap. So every generation is going to have to learn something. The old people are going to have to pull their heads out of their asses, and the young people are going to have to develop higher skills. So I'm going to try and meet in the middle. I think you guys are going to be more willing to develop higher skills than old people are to stop being jackasses. But it's, because I am an old person now, and I know what it's like to go home and be like, no, I don't want to. That old guy mentality of, you're not going to tell me. I get it now. Wow, that really cheered all of you up, didn't it? So we're just going to keep pushing. We're going to keep pushing for higher skills, higher cognitive abilities. So we have the general expression of the rate for this. Now we can use the experimental data to figure out what X and Y are and get the order of each reactant. And so the way you do this is you look at this list and you say, okay, each one of these is a different experiment. And I can look at two of these where I hold the S2O8 ion constant, where its concentration does not change. And then I could do the same thing for the iodide, where its concentration does not change. Now, this is a little note to take because we don't really work any examples like this, but you may see it. If you're working on something like this and two of the experiments that you have to pick, let's say I had to pick these two right here, okay? I couldn't because both ions are changing their concentration, but let's just say I picked that one. Do you notice how the rates are identical? If you have to pick two where the rates are identical, that's a zero order. It's automatic. So you'll get weird answers for X and Y. I've seen people come to me with homework and they're like, I got 0.12 for Y. No, that's a zero order. If the rate stays the same, you automatically know it's zero order. Now, the first thing we're going to do is I want two experiments where that ion is constant. Okay. Well, let's see. I don't know if I have enough room over here on the right to do it, but okay, so the two that I picked experiment 1 and experiment 2. As you see, you have the same concentration, so that's constant. And I'll show you why that's important. Now, I always like to put the bigger number on top. It makes the division come out nicer. So what I said was I'm going to take rate 1 over rate 2, and what that's going to equal okay, now looking at this can simplify down a lot. How can this simplify? Yeah, so what cancels in that on that right-hand side? The K's will cancel because it doesn't matter what experiment it is. This is a singular reaction. The K will always be the same. It's the rate constant. Now, you remember I've held this ion constant, which means the concentrations of that one also will not change. So what I end up with oops. And so out of the table over here, the brackets around iodide mean what? Concentration. So what I'm going to do is I'm going to take the rate for experiment 1, and that's going to be moles per liters times second, over the rate for experiment 2, 6.25, -6 moles per liter times second, and that's going to equal 0.080x over. Now, the left side is pretty easy to do, okay? How do I work the right-hand side not knowing what x is? I can, yes, but why? How can I combine those? Which means I guess you guys have to do it, but some of you on your homeworks, you're displaying like really nice mathematical ability. I'm like, why are you in general chemistry? So, but I guess it's just a step. I guess you have to. I am very happy because that means that you guys got a higher mathematical education than some classes before you. So that's nice. So yes, when the top and bottom have the same exponent, I can combine it into a single fraction held to that same exponent. So when I divide these out, you're 12.5. So I actually don't have to type out on my calculator the 12.5 times 10 to the negative 6, because you notice how they both, like a little shortcut, notice how they both have 10 to the negative 6. I can just go ahead and cancel those out. And any mathematician who watches this is going to go, oh, dear God. So as a physicist all the time, we do things and mathematicians go, you can't do that. It's like, but it works. The predominant one is mathematicians going, derivatives are not fractions. Yeah, but I can cancel them out like they are. So, you know, physicists tend to make mathematicians real mad. But I can divide the 12.5 by 6.25. What I'm going to get is 2 equals, and then 0.08 divided by 0.04 is 2x. Now, the question is, what does x have to be to make this happen? 1. X has to equal 1. So there's one of them. So you divide the 12.5 by 6.25, that gives you 2, equals your 0.08 divided by 0.04. That's also 2. But that side is raised to the power of x. So this right here is 2. This right here is 2. Yeah, because since they're both on the same order of magnitude, that you can shortcut this. If you're dividing two numbers on the same order of magnitude, you can just cut out the times 10 to whatever. So what these are the rates at which concentration will change based off experiment 1 and experiment 2. And so you saw we divided rate 1 by rate 2, and we just put those numbers for those rates in. Yeah. Right. So you get 2 equals 2 to the x. You say, what does x have to be for this to be true? And x has to be 1. Like, for example, if I had 4 equals 2 to the x, what would x have to be? 2. So you have to ask yourself, what does the unknown have to be in order to make this true? Okay, so now I have one of them. Now we're going to do the thing where we hold the iodide constant. Okay. And for this one, I picked 1 and 3. And granted, you could pick any of these that hold constant the one you're trying to hold constant, because when you do this in lab, the one you're holding constant, you're putting in a bunch of excess, because you're like, I want the other one to change noticeably and I want this one to pretty much stay the same. So I'm just put a crap ton of it in, and then I can measure the other ion. Okay, so once again, rate 1 over rate 3. So once again, we have K. So we won't put X in there because we know X is 1 now. Yep, we're trying to find Y. Now, if you really want to see this, you could also put numbers in here and see what cancels out. So if that also helps. So you could say, this time, rate 1, rate 3. Okay, so it's once again, it's going to be 12.5, 10 to the negative 6 over 6.25, 10 to the negative 6 equals K. What is the concentration of I in this case? 0.08 both times. Let's go ahead and put in S208. So that one's going to be 0.04. Well, I'm going to, but I'm just saying in case you couldn't see it without putting numbers in, I'm going to put numbers in this time and you can see everything that equals each other. So if you're able to see that, I had the subscript 1 and 3 on the S208, those are going to be different, whereas the iodide is exactly the same on top and bottom. But now I'm just putting numbers in to show that. And so then this one would be 0.020 Y. And so again, you can see that the Ks are the same and the iodides are the same, so those cancel out. And what you're going to get this time there we go. So this side, again, will be 2. When we do the 0.040 combined to a single fraction, we're going to get 2y. So 2 equals 2y. Y has to equal what? 1. So your rate law for this experiment, for this reaction is that. So you notice I didn't put any exponents in there because we usually, if you're doing an assignment and you will go ahead and put the 1 in there, I'm not going to mark it wrong. Just remember in chemistry, we don't usually put our 1s in. So this is first order in both iodide and S208. What's the overall order of the reaction? 2, second order. Because you add the 1 plus 1 and you get an overall reaction order of 2. Now it says find the rate constant. How would you, so here's our rate law, okay? Okay, how would you use this and the data from this table to find the rate constant K? So I'll put it up here, your rate that we just found. Making it harder than it has to be. Yeah, I pick any one of these experiments and plug in the numbers, solve for K. So what you would do is you would say, well, so then so I just picked experiment 1. Okay, it doesn't matter. You can pick any one of them. Say you're that person, like, I want experiment 6. That's fine. You can do that. You can be that person. You're a weirdo, but you can be that person. Because we all know if you don't think exactly like I do, you're weird. Yeah, people laugh at that because that's how our world tends to act. Most of you don't think like I do. Remember, I'm neurodivergent, so unless you know what an algorithm is and your brain runs like one. That's why I don't get social cues until I have input to adjust the coefficients of the equations. Usually someone has to go, that's inappropriate, and they go, oh, okay, adjustment. Now, so if I pick experiment 1, what I'm going to do is I'm going to take my rate And that's going to be 12.5. 10 to the negative 6. Now remember, moles per liter, moles over liters times seconds. And then 0.080 moles per liter. 0.40 moles per liter. So now, what you're going to get is a rate constant, 3.91, 10 to the negative third liters per moles times second. Now, do you see how those units work out? One of your moles per liter cancels out the moles per liter on top. You still have one left. Moles per liter is on the bottom. It flips, becomes liters per mole. Mm-hmm. And on the top, you still have that S left over that comes down to the bottom. Make sure we know how fractions inside of fractions work. No, you don't like fractions?
Like,
Hey.
it's almost like in math class, I'd always put it in percentages and then do that.
Yeah, well, if
It
you
works sometimes.
now, if you're using your calculator, decimals work really well, but for units, you're going to have to understand like what units you get. But I don't know. By the time you take my physics class, make sure you know enough trig to be able to do work with a right triangle. And for second semester physics, make sure you have reviewed your geometry, because that's how we do optics, geometry. It's not bad. It's just I have a beam of light that comes in here, bounces here, goes there, bounces here, goes there. What are all these angles? It's like, well, I have this angle, then I have a triangle. It's not a right triangle, so I have to figure it out. And then it hits here, and then it leaves at that angle. So we just in the lab, we actually do an experiment, and I handed out protractors, and I swear to you, people looked at me and went, "What are these? Do you guys not use those anymore?"
In like third grade.
Yeah. Well, yeah, it's like a half circle.
Yeah, and then you have.
Yeah. Yeah. I handed those out, and people went, "What are these?"
I like if I maybe would have made them.
Okay, well, good. Then you're ahead of the curve. I was like, wait, what? You know,
Like a teacher like told out of it's like.
yeah, protractor.
It's like
I'm just glad we don't use compasses anymore. Because when I was in school and we used those, instead of actually doing the homework, people were stabbing each other. Yeah, a little point on them. Yeah. They're for like bisecting angles and stuff. I don't either, but yeah, I got stabbed with those so many times. Like they had to take the metal ones away and gave us plastic ones. I got punctured by like the guy next to me in class. He's like, thunk. He goes, "Well, I went right through your skin." I was like, "You think?" So, wow. I guess I expected. Well, I guess I thought I'd need more room than that. Okay. Now, I want you guys to work on this for a few minutes. Here's another example. Because then we're going to start getting into integrated rate laws. It's time for you to bring your calculus out of your memories. Well, if it's not in your memory, we will be sure to smack you with the calculus sledgehammer. What? Yes. A partial derivative of x squared times y is also 2xy. I dropped the first thing. Well, it depends on what your career needs, but. Well, because I looked it up and said, "Oh, low key, like I hate to use that." Once you get used to it, it's not. You just have to remember certain. You have to remember certain formulas, like for example, anyone who takes statistical thermodynamics, like the chemistry 400 level. Like it sounds really bad, but if you can get down your natural log and exponential calculus, you pretty much have the whole semester.
I'm kind of good things and I'm succeeding and I'm like, no, that's
And some of it's just memorizing the formula, like the integral of 1 over x dx is the natural log of x. If you just And so then a lot of stuff we do in physics is working the algebra inside the integral or the derivative to make it look a certain way. And it's like, now I have a solution for this format. What is that? It's just a bunch of different, physics equations.
Yeah, we still gotta get it. Wait a minute,
Yeah. What'd you remember?
Nonsense.
In trade? Oh, like the radium one?
Oh,
That's an R function.
Yep. Yeah, we just gotta.
Whoa.
We're gonna take the same. Try to memorize this. You don't have to let every test do that.
What is for me? Is it good? I'm sure you're
You have partners?
I'm pretty sure we usually start with your length. Times the concentration of, yes, I'm pretty sure our is so. That's why I changed it.
The only thing I can't do with this is pass. I think it's a worksheet, make, I think that we should just.
No, we're not going. There will come a time in those that come your next phone. That's called serial control. Shut up. Excuse me, I was trying to keep. No. I told someone one time, someone told me in class, I'm offended by that. I go, well, let's go through, we're gonna do the thermodynamic calculations for the universe, adding in the energy of your being offended. And as you notice, nothing changed. So the universe doesn't care. You can, it's a very long process just to say, you're offended, too bad. It's really funny once you do it though, because like if you're willing to put the effort into it, yeah, shaving someone's real fun. I don't think making people feel bad on purpose is a good way to go, but I do think we need to bring back a little bit of shame into the world.
I agree. A little bit of the weight is not bad. Just like there's definitely a certain amount of.
Just a little bit.
There's definitely a fine line. For you.
Like, for example, I saw something over the weekend that if you need any more evidence that TikTok is just ridiculous poison. I saw a video, this came across YouTube, someone was making fun of this. And the person was talking about pickled foods. And they said, the person said, well, I've seen pickled peppers and asparagus and pickled green beans, but you know what bugs me is no one's ever pickled a cucumber. And I went, you're joking, right? You mean a pickle? No, they're being for real. I was watching the burnt peanut and the guy he's playing with, he goes, that's gonna be about a square foot. And the guy goes, how big is that? And the burnt peanut, he's like, are we for real? Like, are we super duper for real? How big is the square foot? He's like, I'm gonna guess. And this is just a guess, but I'm gonna say it's probably 1 foot 5. 1 foot. It's just a guess. I'm throwing numbers out there. But he spent like 5 minutes, but did you just ask me how big a square foot is? Did you just ask me that? Was that a question? It just came out of your mouth. Oh, what's up? Yes. Let's see. So you might want to make this be out both lines and the next will go out. So as you're doing it like that, you have 2 numbers, that way you can both imply. Yeah.
The changes,
Yeah, and they're both long. Yeah, or actually, it doesn't matter. X, Y. You can write it next door to the cat. It doesn't matter. I had somebody do that one day, they started drawing little cat faces as their regular list. Well, so, we'll see that more as we go along. It's just your rate law. Is gonna be rate equals that times equals your pay and then your. Just give me an idea of how the overall rate looks like. So you're trying to say, well, what is this actual rate of change of the story? But then you put that to the rate law, and then you define your. Well, you put the following. Yeah. So what was this one? So you chose which two? One and two. Okay, so let me put that one over that one. So put 1.8 over 0.2. You see what that is? These been.
I've done that before, like, if I'm like, yeah, and like, where, and like, there's like, actually, and it's like, God, it doesn't know.
Yes, that's it. That is your rate law. Yep. Now, for the next, try to put the plan number on top of that.
No, it's. He doesn't.
I don't know, but he's just getting greasier every time he gets out of the shower.
I got it. What is your opinion on that?
On just using conditioner instead of shampoo?
No, just using shampoo.
Oh. Depends, I mean, if you're a bachelor living alone, it happens. You know, you're in the shower going, like that.
No, but you just do this like forever, you always done it.
You come out like, you not smell bad anymore?
I don't know.
What? Look, they're all surfactants.
Does your mom buy body wash? We use gloves.
Yeah. And what if you don't have a bar of soap, but you have shampoo?
Well, one time.
Yeah, like it's fine probably to like you get to go and find more, but like if you already going to find more or something else.
I like the show.
Yeah.
That was the most.
I don't ask about shirts anymore because last year I made a mistake. Someone kept wearing shirts that said Bearcats on. I go, where are the Bearcats? And that started a whole thing.
Is it?
Yeah, that's Scott's love Bearcat.
Don't forget about the H&H.
Look, it started a whole thing. Someone said, yeah, that's Scott's Bluff. And someone across the room made a sound. I go, oh, is that a bad thing? They go, no, they just think they're better than everyone else. And the guy from Scott's Bluff goes, because we are better than everyone. It started a whole thing. I was like, I'm just not gonna go there.
Real times.
Okay,
I agree with that.
let's start to take a look at this. So initially, we have to say that our rate law is going to be K. Is going to be that. We have to find X and Y. All right, well. Let's use the two experiments that hold chlorine constant. So that'll be 1 and 2. So I'm going to do rate 2 over rate 1 to get the bigger number on top. So what we're gonna end up with is that. Okay, so that's gonna put, wait, did I do the right ones? Nope, I chose, let me change the numbers, because, well, let me just change this. There we go, that'll work. Okay, so that's gonna be 0.3. Let me change this. There we go. Yeah, I looked at 1 and 2. I looked at the wrong part of my notes. I'm like, fine, we'll just switch it to chlorine right now. So 0.36 over 0.18. And that's going to get, so that my chlorine is going to be what, 0.2 over 0.1. Y. This is going to give me 2 y. Y equals 1. Okay, so then now we'll hold chlorine constant, and that's going to be 1 and 3. No, 2 and 3. Those two. Okay, so to save some time, what we're going to end up with, let's see, rate 3, rate 2, and that's going to give me so what? That's going to be 1.45 over 0.36 equals 0.2, 0.1 x. Now this is going to give me something at about 4.02 equals 2x, which we can round to 4 equals 2x, x equals 2. So my rate law and CL2. So that's my rate law. And so then for part B, what is the rate constant? So you, again, you pick one of the experiments, you plug in the numbers, your K, I shouldn't have to go all the way through this. Your K should be about 180 meters squared. So after you get the rate, pick one of the experiments, plug in the numbers, solve for K. Because you go back up, you have your concentration of NO down there, concentration of Cl2, and then your rates.
Like the rate, it's just the rate is spinning.
Yes.
It'll be like, went up. It would be 0.18 and divided by.
Well, are you talking about plugging in the numbers?
Yeah.
So what I would, let's just say I picked,
Yes, 8 divided by 0.1.
for example, I picked experiment 2 because I picked experiment 1 last time. So I'm going to plug in that for the rate equals that squared times that, and then K is the only thing I don't know. So I'm going to take that rate. Yeah. So I just plug my numbers in.
Oh, there's no. have or whatever
Oh, awesome.
for